Okay, today we're multiplying and dividing rational expressions. So, I know this is super corny, y'all, so bear with me as I read this out loud. It says, dividing fractions as easy as pi, just flip the second and multiply. Okay, super corny, but you love it. It's just your reciprocal. When you flip a fraction, that's your reciprocal, yes? So, don't let division scare you. All you have to do is you're going to rewrite the first one exact. Didn't change the first fraction, right? It's still the same. I'm going to change it to multiplication, and I'm going to flip what was after my division symbol. I'm going to write the reciprocal. So this becomes 24mn over 35cd cubed. Now does it look that terrible? Division, I feel like, scares everybody. It's not. Don't worry. Okay, the cool thing is with the coefficients, can we do that in our calculator? The numbers. Yeah. So we're going to ignore the letters for a second. We're going to come to our calculator, alpha y equals enter. Always type it as a fraction, because if not, it's going to give you a decimal, and you're going to be like trying to give me decimals, and that's not what we're going to do. And we have 14 times 24 on top over 9 times 35 on bottom. So it's going to multiply them and simplify them all at once. And that gives me 16 over 15. So now I don't have to worry about my coefficients at all anymore. And I'm going to rewrite my letters. You don't always have to do this step, but I'm going to, because I just want to make life easy, alphabetical order on my top and bottom. So C, D, M, N is alphabetical order. So C squared, D, M, N. And then the bottom, C and D come before M and N. So C, D cubed, M cubed, N squared. So I just wrote it in alphabetical order so we can simplify them simpler altogether.
I'll do this.
Are you okay with where I got 16 over 15?
Mm-hmm.
Okay, so all I've done right now is because when you're multiplying, literally this is saying 16 times C squared times D times M times N. That's all this is. But when you're multiplying, so all I did was rewrite my letters and just put them together so I can simplify them easier. And I put them in alphabetical order so they line up with their like letter. So the top ones were already in alphabetical order, so that was good. But the bottom, I just flipped-flopped them. So nothing changed, they just switched places. So that way they lined up with their same letter. Okay, and now when we're dividing, what do we do with exponents? We subtract them. So 16 over 15, and if there is no exponent, just remember it's a 1. Okay, so 2 minus 1, well, first off, where are there more? More C's. Sorry, more C's. Top. 2 minus 1 is 1. Do I have to put a 1? No. You can. Will you be wrong if you put a 1? No. Where do I have more D's? Bottom. 3 minus 1 is 2. Where do I have more M's? 3 minus 1 is 2. Where do I have more N's? Bottom. 2 minus 1 is 1. There is your answer. So could you have probably skipped this step and not rewrote your letters? Yes. You could have paid attention across. That's fine. I just wanted to put it in order so you could see what we were doing. Yes? Cool. Okay, look at number 2. What's different? It's not as pretty because what changed? So on number 1, I want you to realize there was no addition and subtraction. So it was just multiplying, which made life really easy because there was no factoring. This one has addition and subtraction, meaning we have to factor every single piece. Now the the con, we're going to factor all 4 pieces together, which is a pro and a con, I guess, because we're going to do it together. But on your test, y'all, I'm not trying to make y'all take 20 minutes on a problem. So I am going to factor half of it for you. So it's going to be partially factored for you. Does that make sense? So it's not like I'm going to give you a problem that's like number 4. Number 4 is not fun, but I'm going to factor that one for you too. And just be like, haha, good luck. Finish your test in 50 minutes. Okay. it's going to be partially factored for you, so you are going to be factoring on your test, but you're also not going to factor a ton. Yes? I'll help you out. Okay, so look at number 2. We're going to start on the left side because if you're like me, you don't want to rewrite it a billion times. Okay? We're going to start on the left side and we're going to factor it as we go before we rewrite it, so that way you're not rewriting it a billion times. We're going to start. Is it in order, top left? Yes. Does it have a GCF? What is it? 5x to the third power. And when I take that out, this is me writing dividing by 5x cubed, dividing by 5x cubed. It's hard to see, but I promise that's what it says. Well, the 5's cancel, and then we subtract. So what's 5 minus 3? 2. 20 divided by 5 is 4, and the x cubes cancel. Now, when you still have an exponent, always pay attention to see if you could break it down further. Can this keep breaking down? Yes, it's a perfect square minus a perfect square. So what squared minus what squared? X and 2. So I'm going to bring down my GCF. And what does that become?
X plus 2x minus 2.
Yeah, x plus 2x minus 2. If you wrote x minus 2x plus 2, is that okay? Yes. Order doesn't matter when you're multiplying. So you can flip-flop them if you want. Now let's do the denominator, because we're going to work on the fraction that we're not flipping first. Yes? So how are we going to factor this? Well, how many terms do you have? 3. How do you factor something with 3 terms? The box. Now, do we have to go all the way to the box with this one? No, why not? Because a is 1, yeah. So I'm going to come over here so I don't mix up my simplifying with my factoring. Yes?
What's that writing next to the 5x?
It's just divide by 5x cubed, divide by 5x cubed. Because that's me taking out the GCF to see what was left. Okay, so I have A, B, C. A is 1, B is negative 1, C is negative 2. A times C is negative 2, B is negative 1. Y'all, I want you to realize 2 is prime. The only thing that multiplies to give you 2 is 1 and 2, but one of them has to be negative. Which one's going to be negative to give me a negative 1? The 2. So the positive 1 and negative 2. So what does that give me for factors?
X minus 2x plus.
Yeah, x minus 2, x plus 1. Now I'm going to change this to multiplication because we don't like division, and we're going to flip what's after our division symbol. So I'm going to start on the bottom, but I'm going to write it on the top, yes? How would I factor x squared minus 1? Is it factorable?
Yes.
Yes, don't let 1 throw y'all off. Sometimes 1 really throws y'all off. 1 is a perfect square. It's also a perfect cube. It's also a perfect to the 4th power, to the 5th power, to the 6th power, or root, or whatever. It's all of the things. So what squared minus what squared?
X.
Well, x and 1. So what is that as factors?
X plus 1, x minus 1.
So remember that was on the bottom, but now it's on the top because we're flipping. So looking at the top that we're now going to write on the bottom, that's a lot. It's 3. They all have big exponents. So let's start. Is it in order? Yes. Does it have a GCF? Well, yeah, they all have an x, so we can at least take out an x. How many x's? X to the cubed, x to the 3rd power. So when I take that out, I'm left with 2. Then I'm left with 1. And then these cancel, so I just have the minus 2. Oh, I just wrote x. Sorry, x, not 1. Now we have a trinomial. I'm going to bring my GCF down so I don't forget it. So I'm going to have to do this. Now, is that super similar to this? What's the only difference?
It's positive 2.
Almost. Well, yeah, so for the factor, you're right. The b is positive 1 instead of negative 1. So what that does, y'all, is all it does is make this a negative 1 and a positive 2. So you're exactly right. So we have x plus 2, x minus 1. Okay, now this mess is fully factored. That's the worst part. Now's the easy part. Okay, that's the gross part. Now it's the easy part. Okay, so here's a question I have. If you have 2 things on the top that match, we don't on this one, But if you did, can they cancel each other if they're both on the top? So like if you had x minus 2 over x plus 1, would those x minus 2's be able to cancel each other? No, because they're on the same level. Okay, so what I want you to realize is to cancel, they have to be one on top, one on bottom, because it's dividing, right? And when you divide something by itself, doesn't that equal 1? And multiplying by 1 doesn't change anything, and that's why we kind of just ignore the 1, right? So when things cancel, what if everything canceled? Like what if this had an x plus 1 and this had an x minus 2? So if everything cancels, what's my answer? 1. I know I just made up random factors, so don't let that throw you off. We didn't factor anything. I was just making up random things. But what I want you to realize is if everything cancels, it equals 1. And to cancel, one has to be on top and one has to be on bottom. Two tops cannot cancel each other. Two bottoms cannot cancel each other. Does that make sense? Okay. Also, this is multiplication, meaning I can close this and you consider this all one top and all one bottom. So this can cancel this and this can cancel that. Yes? They can cancel across. So like this x plus 2 cancels this x plus 2 on the opposite side. Because when you're multiplying, this all just goes together. All just goes together. So this x minus 2 cancels this x minus 2. X plus 1 cancels x plus 1. X minus 1 cancels x minus 1. And then I'm left with 5x cubed over x cubed. Well, can I cancel the x cubes? Yeah, because there's no plus or minus, so they're not stuck to anything. And what's my final answer?
5 over 0.
Not over 0, 5 over 1, or just 5. Because you remember, you don't have to have something in the denominator. If you're like me, I also feel cheated that we did all that work for 5. But it's not my problem. I believe it's from the textbook. A lot of my practice problems that I get out of the notes I get from the textbook strictly because that's what district goes to for y'all's tests and stuff. And I always want to make sure I'm teaching y'all what I know they're going to put on there. So a lot of what I get on my notes when I made it comes from the textbook just to make sure I'm teaching you what. Now some of them are a little crazy and I'm like, we're going to skip that one. Because textbook get a little wild sometimes. Okay, look at number 3. Is everybody okay on number 2? Okay, look at number 3. Number 3 is not as bad. I don't think it's as bad. Number 4, that's another story. We'll do that one together. Don't stress about number 4. Okay, look at top left. Now, what's different about number 3 before we keep going? What's in the middle? It's multiplication. So do we have to flip anything? No, it's already multiplication. We like multiplication because then we don't have to worry about flipping anything. So we can literally consider this all one fraction. Yeah? And we're just going to break apart all the pieces. So I'm going to start with the left just because that's how my brain works. And we'll keep going. So again, I like to factor over here so I don't mess up, like make a mess and lose myself. I have A is 1, B is -1, C is -6. What goes on top? -6. What goes on bottom? -1. Be careful, make sure it's negative. What multiplies to give you -6 and adds to give you -1? That's fine. Yeah. If you can, cool. If not, no worries. Yeah. -3, +2. So A was 1. Do we have to do the box? No. So this becomes x minus 3, x plus 2. Now, we like the denominator. Why do we like it? Yeah, there's no exponent, so worst case scenario, you take out a GCF because you can't factor it other than a GCF. So does it have a GCF? Yeah, 2. So let's take out the 2. And that leaves me with x minus 1. See? I told you we like that one. Okay, now let's do top right. Like again, you don't have to flip it because it was already multiplication. What's wrong with the top right? It's not in order. Our x is supposed to come before our 1, but when I put it in order, what does it look like? Perfect. -x plus 1. Don't just flip them. The x was negative, the 1 is positive. But can you have a negative in front? No, you have to take it out. So I'm going to divide by -1, and I'm going to take out that negative. Now I want you to realize you can put a -1 there if you'd rather, or you could just put a negative, it doesn't matter. And that cancels, and you get x minus 1. So just know when it's out of order and it has a negative, it's still going to be subtraction, but it's also going to have a negative in front. Okay? If you can memorize that rule, that's awesome. If not, just you're going to have to do that every time. I don't expect y'all to memorize that rule. I don't want you to think I'm saying that. Okay, and then we have to factor that other one. So A, I'll do this one for y'all. B, C, 1, -2, -8. A times C is -8. B is -2. It's going to be -4, +2. So now we can cancel. So we have x minus 1s that cancel. We have x plus 2s that cancel. And we have absolutely nothing else that cancels. So I'm going to rewrite it. Now your coefficients that don't have, like your constants that have nothing, so not coefficients, but those are going to go in front of everything. You good? So we have -1, or just negative, in front of x minus 3, over 2x minus 4. Can you cancel these x's? No. Because they have that minus sign behind them. Even if they had a plus sign, you can't cancel them. Remember, when they have that minus or that plus, that makes them stuck together. And their baggage, that 3 and that 4, don't match, therefore they don't cancel each other. This x plus 2, yeah. So if their baggage matched, like if they were both x minus 3, then they could cancel. But they don't. Their baggage is different, so they can't join each other wherever. Okay, so there's your answer. Did y'all know that negatives are flexible? You can put a negative on the bottom or the top. It doesn't matter. Okay, so if you have a negative on the bottom and you want to move it to the top, is that okay? Yes. If you have a negative on top and you want to move it to the bottom, that's okay also. It doesn't matter. Okay? Negatives can move anywhere. It's still going to be negative. Yes? As long as you didn't change it to like a double negative, you're good, because a double negative makes a positive. Okay, last one. Don't hate me. I'm going to do it with you. I know. Same at this point after doing it 6 times, but it's fine. Okay. Almost. Almost. Okay, so these are cubes. This is a perfect cube minus a perfect cube. Am I ever going to make you memorize the formulas? No. Have I ever made you memorize the formulas? So I'm going to remind you of them. You don't have to write them down because I will have them on the board for this, for the test, okay? You don't have to memorize the formulas. So we know that a cubed minus b cubed, that's your formula, or how you find a and b, equals a minus b, a squared plus ab plus b squared. So this is the difference of cubes, not the sum of cubes, because that's not on here. And then the squares, a squared minus b squared, which we've already done one, but that's a minus ba plus b, or a plus ba minus b, doesn't matter. So again, you don't have to memorize those. I'm just writing them down so you're not like, oh my gosh, you're a crazy person. Where are you getting those numbers, letters, whatever? Okay? So if you look at the top, it says x cubed minus y cubed. Well, that's obviously a perfect cube and minus a perfect cube because they're both cubed. So, well, the nice thing is it's literally almost written exactly like this, just with an x and a y instead. So we know that a becomes x and b becomes our y. So I'm literally just going to rewrite this, y'all, and instead of a, what am I going to put? X, and instead of b, what am I going to put? Y. So I get x minus y, and be careful because last period I wrote b instead of y, so just watch me. A is x, so x squared, plus a times b, which is x times y, plus b squared, which is y squared. I didn't do it this time. Getting somewhere. Okay, and the bottom is very, very similar, except this time it's a perfect square minus a perfect square, so x and y, a is still x, b is still y. It's x minus y, x plus y. Okay, so these are both grouping. How do I know that? How many terms do they have? 1, 2, 3, 4. 1, 2, 3, 4. I'm going to do one of them for you, I'm not even going to show you all the work to stress you out because they're both done exactly the same, right? Does grouping ever change the way we do it? No. So I'm going to do one of them for you. I'm going to do the bottom one. It literally is just x squared plus y squared and then z plus 2. But we're going to do the top one together just as a refresher on how to factor with grouping. Yes? Okay. Yes. Okay, so this is a degree of 1, degree of 1, degree of 2, degree of 2. So is it in order? No. Degrees of 2 should go before degrees of 1. Remember, higher degree to lower degree. So I'm literally just going to take these two and put them in front of those two. The sucky part about order is if you don't fix it in the beginning, you'll just have to fix it later. Now, with all of this being plus, it's really not hard to change order whenever it's adding, so it's not a huge deal on this one. But when you start throwing in minus, it gets a little complicated, okay? So here we have xz plus yz plus 2x plus 2y. So I fixed the order. And how do we factor with grouping? Do y'all remember? We cut it in half. So we do 2 terms on the left, 2 terms on the right. So that's us grouping it. We're cutting it in half, we're grouping it, yes? And then we find the GCF of each group. So what's the group of our first half? I mean the GCF of our first group. Z. Don't they both have a Z? So we're going to take that Z out, divide by Z, and when I take it out, what do I have left? X plus Y. So there's the left side. What's the GCF of the right side? 2. Positive or negative? Do y'all remember how we know? That first one. So this first one's positive, so we're going to take out a positive, and they both have a 2. So divide by 2, divide by 2. What do they both have left?
X.
Now, we want these to match. Did they match?
Yes.
Then we take it out like it's a GCF. And then we cross it out. What was left after we crossed it out? Z plus 2. That's why I draw a line through my Z so you can tell the difference.
So what if
I didn't start doing that until I taught algebra.
what if the x and y cancel out?
Well, hold on. Yeah, hold on. So now we can start canceling things because everything's fully factored. So my Z plus 2's cancel. My x minus y's cancel. My x plus y's cancel. Does anything else cancel? No. Yes, these both have an x squared and a y squared, but they have plus signs, which remember makes them stuck like glue, and they don't match exactly. Their baggage is not the same, so they cannot cancel each other. Therefore, your answer is x squared plus xy plus y squared over x squared plus y squared. Not me. I'm insane, but here we are. Not me. Okay, so do you see what I'm saying is you can't cancel those x squareds, y squareds because you can't separate addition or subtraction to cancel. Only multiplication. Yes? Okay, I'm going to help you out on the practice. Are you ready? I'm helping you. I'm going to factor some things and I'm going to cross off the super gross one. Yes? Because I'm your favorite. It's okay. You don't have to agree to it. I already know. Okay, look at number 6. Look at number 6. I'm just doing this, y'all, so it doesn't take you as long. I'm just trying to cut out some time for y'all. You will have time to work on this, so don't stress about that part. Not right this second. Wait till she gets back. Now you can. So that's what that gives you. So on number 6, the top left is that, and the bottom right is this. Oh. Okay, 1 minute. Like literally 1 minute. Okay, so I factored those two pieces for you on number 6, yes? Everybody okay with that? Okay, now flip to the back whenever you're done writing that down. You're going to cross off number 15. It's super gross. I promise you number 16 is not as bad. 16 is mostly GCFs, while 15 is a bunch of trinomials that need the box, and it's just, it seriously takes up most of the paper. It's a waste of life. I'm helping you. Okay, so cross off number 15. Don't do that one. Okay, I'll put it back. Hold on.
Isn't there a way to just put this on the calculator?
So I took off 15. Okay, and then look at number 9 and 10. Number 9, bottom left. And then 10. Okay. So that was, might help if you could see what I did. That was just me trying to help you cut out some factoring.